All right, so we're coming now here to the end of the factoring the trinomial completely part. I think we have 32, 33, 34, and 35. So this video and one more, and then we'll be into another section. So let's go ahead and take a look at 32 and see what we've got. They've given us 2x cubed plus 6x squared y minus 20xy squared. All right, question 1. Is there a GCF? And, well, let's see. We have a 2, a 6, and a 20, so we can definitely pull out a 2. We have an x cubed, an x squared, a single x. So remember from the first part of the review series, when we're dealing with variables and their exponents, we take out the smallest exponent. So in this case, we're going to take out just a single x, right? Because the exponent here is 1. So between 1, 2, and 3, 1 is certainly the smallest. All right, and let's see, how about y's? Y squared, a single y, but no y here, so we can't take out a y. So it looks like our GCF is going to be 2x. And when we take out that 2x, let's see what we're left with. Well, we can go ahead if we want and use that little trick from the beginning of the review series where we rewrite the original expression that we were given. And under each term of the original expression, go ahead and write your GCF, what you've taken out. And then go and reduce, just like we did with the previous test. So let's see, our 2's cancel. And now we ask ourselves, are we top heavy or bottom heavy on x's? Well, let's see, we're top heavy by how many? Well, 3 minus 1 is 2, so we're left with just an x squared. And we have plus, so plus. 2 goes into itself once, 2 goes into 6 3 times. And x cancels with one of the x's on top because we were top heavy by 1. And then there are no y's to cancel, so we're just left with a single y. So we have 3 times our single x times y, so we have plus 3xy. And then lastly, we have our minus, so we'll put a minus, and then 2 goes into itself once, 2 goes into 20 10 times. The x's cancel, and we're just left with y squared. So that minus 10y squared, so minus 10y squared. All right, and now we've been left with just a relatively simple trinomial to factor, right? Let me go ahead and make some room and get rid of that. Well, we know that a trinomial factors into two binomials, so let's go ahead and create our blank sets of parentheses here. And we're dealing with an x at the beginning, so x at the beginning. We're dealing with a y at the end, so y at the end of our parentheses. And now we're looking for factors of 10 that subtract to give us a positive 3. Well, if we list the factors of 10, we have 1 and 10, 2 and 5. Which of these are going to give us the combination that we want? Can we get a positive 3 out of 1 and 10? No, I don't think so. But here, 2 and 5, we can, right? If we have a positive 5 and a minus 2, well, 5 minus 2 gives us positive 3, and 5 times negative 2 gives us negative 10. So there we have it. And again, if you're not sure, go ahead and FOIL this out, and then whatever the result of this FOIL is, distribute your 2x through, and you then should wind up with what you originally started with. All right, number 33, let's go ahead and take a look at. We're given 10 quantity p plus 1 squared plus 19 quantity p plus 1 plus 6. All right, these are pretty fun. We can see now that we're dealing with something a little bit more complicated, right? Instead of just a single variable as what's being, the variable itself being a single letter rather, now we have a quantity, right, that's acting as the term, our variable term. And so when you come across this, what you're going to want to do is choose a letter, and we're going to use substitution in this factoring problem. So you're going to choose a letter to represent the quantity p plus 1. And what I mean by that is, let's go ahead and choose another color. And let's say, let u represent the quantity of p plus 1. So anywhere you see a p plus 1 in the original expression, we are instead going to replace that p plus 1 quantity with the letter u. And so what does that look like? Well, now we're going to have 10, and now our u squared plus 19 u, and now plus 6. So all we did was we took the letter u, and you don't have to use u. You can use, really any letter you want, but u is a pretty common letter to represent a substitution with, because very rarely will you see u used as a variable, but any letter works. I would recommend not using p though, right? You don't want to confuse yourself. So use any letter that is not being represented in the quantity that you are dealing with. And all we're going to do now is rewrite the original expression, our original trinomial, using this u substitution. And now we have something, don't we? A trinomial that looks relatively benign, something like we're used to working with. So let's go ahead and work with it, just like we've been doing. We're going to look for factors of 10 and factors of 6 that add to give us a positive 19. So what are the factors of 10? Well, we have 1 and 10, 2 and 5, and we have 1 and 6, 2 and 3. And again, let's go ahead and choose the factors that are closest together. 9 times out of 10, these will be the ones that work. So let's stack 2 and 5, 2 and 3, and if that combo doesn't work, we'll try 3 and 2. All right, so we're going to cross multiply here. Here's the scissors. 2 times 3 gives us 6. 5 times 2 gives us 10. Can we, in some combination, add a 10 and a 6 or a 6 and a 10 to get positive 19? No, I don't think so. So let's go ahead and get rid of that combination. And now we're just left with pairing 2 times 2 is 4. 5 times 3 is 15. Can we, in some combination, add 15 and 4 or 4 and 15 to get a positive 19? Yeah, I think we can. Well, what does the sign of each of these cross products have to be? Well, if we put a plus here with the 15 and a plus here with our 14, 15 plus 4 does give us a positive 19. And remember, whatever sign we put with the cross product just bounces over. Whatever sign we put with the cross product bounces over. And now we're going to go ahead and group the factors that we were working with. So here we're going to end up now with 2, and we were using the letter u, plus 3, so plus 3, and 5u plus 2, so 5u plus 2. And you might be tempted to say, all right, there I am, I'm done, 2u plus 3, 5u plus 2, but you have to remember, what did u represent? We said u represents p plus 1. So we have to go back now and substitute the p plus 1 in for u in our factors. So really we're going to have 2. Now substitute p plus 1 in for this u. So p plus 1 and now plus 3. And here we're going to have now 5. Substitute p plus 1 back in. P plus 1 plus 2, and then go ahead now and simplify this. So we can distribute this 2 through, and we're going to get now 2p plus 2 plus this 3. And we'll do the same thing here. We'll distribute the 5 through. So we end up with 5 times p gives us 5p, 5 times 1 gives us plus 5, and then we have our plus 2, which wasn't affected by this distribution. But now we have a situation where we have some like terms that we can combine, right? And so for the last time, 2p, and what is 2 plus 3? Well, that gives us 5. And for our last factor, we have our 5p, and 5 plus 2 gives us 7. And so there we have the factored form of number 33. All right, these are fun. I like doing these. Our u substitution. Just remember, at the very end, do not forget to substitute back in the original quantity that you let U represent. And that's why I recommend using the letter U. Because U is not something that we usually work with, it might be a clue that kind of tells you, oh, right, we don't usually work with U. U means something. U is representing something. Whereas if you use something common like X or Y or Z, since we are used to working with those variables, when you get to this step, you might see, 2x plus 3, 5x plus 2, and go, oh, I'm done. Whereas if you have a U here, something that's unique or unusual, it hopefully will trigger something that tells you, oh, I'm not quite done. I need to make sure that I go back and substitute in what U represents. All right, I think we actually have one more of these, our U substitution, to do in the next video. So let's go ahead and take a look. See you there.